video we are going to see design and analysis of a beam. So first we have to select new project. Click on new project. We will be seeing a dialog box. Here we have space, plane, floor, trusses. According to our requirement we have to select this. Now we are designing and analysis, doing a designing and analysis of a beam. So we have to click on space. Now we have to give a name of this file. So we are doing design and analysis, so we have to do analysis of the beam. Here we can select the location where we have to save our file. Okay, my file is saving in desktop new folder. So now we have to set up the units, length units and force units. In length units, generally we have these types. In this start pro, we generally give units in meters. In force unit we give kilonewtons. After setting these all, we have to click on next. So we are doing analysis and design of a building, for beam. So we have to click on add beam. This dialog box will give the information about this. Begin building your model by creating new joints and beams using the construction grid, drawing tools and spreadsheet. After reading this, click on finish. We will be seeing this type of interface after opening this. So here we have file, edit, view, tools, select, geometry, commands, analyze, move, window, help, all this. With the help of these tools, we will be creating our model. So first we have to click on setup. Here we can give our job information. So we are doing the design and analysis of beam. Design and analysis of beam. Client say X, Y, Z, and job number let us give 1. As this is the second video, we have job number. Engineer, let's say checker, save, and approve, say C. Okay. After giving the job information, we have to click on geometry. Here we are creating a model of a beam. So firstly we have to select the node. Okay. I am taking a beam of length 5 meters. So I have selected each line is at 1 meter distance. So I have selected these two nodes to create a 5 meter beam, 5 meter length beam. So we can check this dimension by clicking on this. So display dimension to view means it will give the dimension of the all structures. So display, it is showing that 5 meter. After clicking on remove dimension to view to all. So okay, display or remove dimension dialog box will consist of display and remove. If you want to display the dimension, we can click on this. Dimension to view means it will display the dimension of all the elements. This dimension to the selected beams means specifically if we select each one, we have to click on the dimension to selected beams. Dimension to list, we have to give list from beam 1 to which beam we have to give. So clicking on display, we will be having the desired dimension. If we want to know the dimension of all the elements, we have to click on the dimension to view. We don't want any dimension right now, so click on just remove and dimension to view. Now close. Now we have this one is the snap grid, snap node or snapping grids. Okay, to remove grids, click on this. We will be having that. This one is called as data area. So in x direction, node 1. These are the nodes x, y direction. We'll be having the meters. So node 1. So node 1 x distance. This one will see our direction of the coordinates. Upward we have x, y direction, and here we have x and z direction. It will be the 3D we draw or create model in 3D structure. So we have 3 coordinates here. So node 1 is at 2 meters in x direction, and y it will be having 7 meters. So these are the coordinate values. So beam, this one, okay, autosave will save your file. Now do you want to proceed? Click on yes. Structure has been modified. Click on save. Beam node A, node B. So this is called. So if we have clicked this, black box is has formed. So this box is giving the information about this beam. So node A is 1 and node B is 2. Okay. If you want to know this, if we have clicked on this row, that specific node has been selected. So now we have, if you want to know the dimension, so we have to click on node cursor, then only we can click on that node and we will be see here we are having the coordinates about the node. Okay, so this one is the beam cursor. So by clicking on this, selecting this cursor, we can select the beam. By clicking on this cursor, you will be having the cursor, plate cursor. Okay. After so it is the beam. So we have given the element. We have formed a beam. Now we have to go to the general. In general, we give the properties like which material it would be or a dimension. We are selecting a rectangular beam, so we have to give the dimension. YD means height and breadth. Z dimension along y direction is YD, dimension along z direction is ZD. Let's say YD is I am giving the 0.3 meters and this one 0.2 meters. 0.3 meters means I am giving 300 by 200 mm dimension. So which material could be? I am designing a concrete beam, so I am selecting the concrete. Okay, click on add. After clicking on add, we have to assign this to our beam. So click on that. Click on this beam. So we will be having assigned to selected beam. Now get assign. So required property has been assigned to this beam. Okay. After clicking on that, we have to give the supports. So click on the support. Create. If there are many types of supports, fixed pin, fixed butt, restrained, all this. Pinned, fixed butt, release at twist, fine spring, enforced. So we are taking only fixed pin. Okay. Now clicking on this support. Use cursor to assign. We have to click on that node each point. That support will be okay. Assigning. Okay. We have assigned the fixed support at 2 endpoints. We have assigned fixed supports. After that, we will be giving loads. In loads, click on load case details, add. So generally on beam we will be having a dead load, and live load is negligible in the case of the beams. Only beams if we are if we are creating a model of the single story building. So there we will be having several types of loads. In only design of a beam, we will be having a dead load. So load case 1, what type of load is there? Dead load. So mention that one. Okay. Then click on add. So we have added a dead load. By clicking on this, we have to select that beam. Okay. After clicking on add, we have to generally in only single beam design, we will be having only self weight of the beam. Generally we give self load in y direction. Self weight will be the in downward direction, so we will be giving y direction, and minus y minus, since the load, self weight load is acting in downward direction, we will be giving minus values. Generally the factor of the self load, self weight will be the minus 1. Click on add. Okay. Now we will be adding another force, which is member load. Let's say a concentrated force of Gy means gravitational y direction in downward direction. So okay, let us give minus 30 kilonewton. What is d1? The length. What is the length of our beam? So 5 meter. Let us take this point load at 4 3 meters. Distance D2 is, we have given the dimension to our beam as 300 by 200. So half of the D2 is half of the ZD. So we have given the ZD value as 300. So 300 by 2 is 1500. 150. So in meters we have to give, so 0.15 meter. So click on add. So click on self weight. Self weight will be acting on whole beam. So assign to selected beam. Click on assign, yes. So this point load will be also assigned to view. So assign. Click on yes. So we will be having this on this. We have given all this. Click on material. General we will be having a concrete beam. So I have to go assign. So yes, click on yes. After giving all this, click on analysis print. So we will be having different print option: no print, load data, static change, static load, mode shapes, both on. These are all print options. Currently we are not taking any print, so I have clicked on no print and add. Okay. Now we have to go to analyze, then click on run analysis. So it is asking us to save this file. So see, it has analyzed our model and we got 0 errors and 1 warning, 0 notes. So warnings are generally what we have done mistakes. So generally warnings are common in this. So if you want to see that warning, we have to view out. Click on view output. View output file, go to post processing mode, stay in modeling mode. Post processing in the post processing mode, we can see the output such as force, displacement, all these we can see. Stay in modeling mode means this current mode is modeling mode. Okay, we have to, as this has given one warning to us, so we have to click on view output file. Done. So here we can see this. Click on this warning. So where is it? Warning. All degrees of freedom fixed. Start will, okay. This warning has been. Generally warnings can be ignored. So total primary load case is 1, total degrees of freedom is 1. So as we have given the support as fixed, we will be knowing the degree of freedom. Okay. We have analyzed it. Now we have to go for the design part. In this, as it is a concrete beam, we have to select the code. Okay, we have to select the concrete, and now we have to give. Here we are having many types of codes which is related to the which are on the concrete. So we will be using IS 456. Click click on select properties. Generally we will be having compressive strength of the concrete, minimum yield strength of the shear reinforcement. Main reinforcement, shear reinforcement, we will be having two reinforcement of steels. So yield strength of main reinforcement, yield strength of shear reinforcement. Click on OK. And now we have to define those parameters. So we have to define parameters means we have to assign the values for these parameters. Compressive strength. Now I am taking the 35 grade concrete, so we will be having 35,000 kilonewton per meter compressive strength of the. Okay, click on add. Yield strength for main reinforcement of steel. Generally it will be 450 pascals. Okay. This one will be, we have to assign 4,000. Then click on add. Okay, we have to close this. Now we have to add, assign those values to the beam. So first we have to select this beam, click on this and assign to selected beam, assign, click on yes. So this parameter has been assigned to this beam. Next this we have to assign. So use cursor to assign. Select this beam, assign to select beam, assign. Click on this one. Again we have to select this beam, assign to selected beams. Yes. Okay, we have assigned this. Now we have to, as this is a single beam, we have to click on design beam and add. Close. Design beam. Now select the beam, assign to selected beam. Yes. So after giving all the parameters and commands, we have to again click on analysis or print. So we are not taking any print, so I have selected no print. Click on add. Again run analysis. So save. We got 0 errors and 1 warnings and 0 errors. So which warning we have got? So click on to view warning or errors, we have to click on view output file. So done. So that all. Okay, we got that one also. Start will infinite in the release moment x at first joint enter. So to view the output such as forces and actual force or moments, we have to click on post processing. So we have selected only dead load. We have only given the dead load. So click on OK. So here in this post processing we will be having node, beam, animation, reports. In node we will be having displacement, reaction. At node we will be having reactions. Okay, so axial force, click on axial force. Axial force will form on the beam, so we have to select first beam, and next click on fx. Fx means axial force. These are the output: axial force, shear, torsion, bending, torsion, etc. These are the outputs of our design beam. So here we can see the values: forces, stresses, so we have to select the section panel. Select profile. This is the main output. Here stress has been added to the beam. Here graphs. So this one is the MZ, moment, or we can say the torsion. The force in y direction, the force in x direction. Okay, these all we have. So our design of the beam has been completed. Thank you.